Hey everybody, Mr. Toad here. Welcome back to another anatomy and physiology flipped lesson. And in this lesson, we're going to be taking what we learned about the muscular system and how muscles work on a cellular level and how they're organized. And we're going to be looking at the bigger picture now. So how do muscles and those muscle cells actually work together to make an entire muscle move? And then how do we name certain muscles? Okay. So, oops, sorry. So looking at our functions, right? And we've talked about these when we talked about the entire muscular system as a whole, but specifically with our skeletal muscles, right? The ones that are voluntary, they're striated, they're used to move our skeleton around, they connect to bones, right? What are the actual functions of them? So obviously the biggest one probably is producing movement, okay? And that's, again, because they're voluntary, we can control our muscles and our body and move it around, spirit fingers, right? Or jazz hands. I don't know which one's better, but right, they can produce movement. All right, they help us maintain posture. So I've been sitting here in front of this computer for seems like hours today, but I'm sitting here. That my muscles are maintaining posture. I'm actually not thinking about that, but the muscles in my back, my lower back, my neck, my abdomen are actually helping me sit up straight and maintaining that posture. Stabilizing joints, right? So our joints, as we remember, we talked about in a previous lesson where two bones meet, okay? Those muscles help stabilize those joints so they're not moving around. And they stay still and they have structure for when we move them, okay? Another big one here for skeletal muscles, they generate heat. And that's why if you think about when you get really cold, your whole body starts to shiver, right? That's your muscle cells contracting and firing back and forth to create some heat. And most are attached by tendons to bones. All right, so we've talked about tendons and ligaments, right? Connective tissue. But those tendons are these things that connect muscles to bone. And we're talking about skeletal muscles. So moving our bones, moving our skeletal system, it all depends on those tendons, right? And if you've ever had like a chicken wing on the bone, when you chew down on the meat, which is muscle, all right, and you get down towards the end of it where it attaches to the bone, get that chewy white stuff. Well, that's a tendon that you're chewing on there. Okay, and you can see all the tendons here in the foot. Really cool. Looking at all these muscles that come down our lower leg, attaching to our ankle and the bones of our foot. So those are the functions of the skeletal muscle system. But let's talk about muscles and body movement. All right. So how do we actually move? Well, movement happens because a muscle is moving an attached bone, right? The bones in our body that give us structure move around when the muscles pull on them. And muscles obviously are attached at least 2 points, because if they are only attached to one side of a bone, how would they be able to move it? It would just sit there and do nothing. Okay, and we have names for these two attachments. It's called origin and insertion. So the origin, think about where it originates, right? Attachment to a movable bone, and the insertion, attachment to an immovable bone. So looking here at our biceps, right, we see the origin is up here on the humerus, the insertion's down here on the ulna, all right? And again, so that muscle has two attachments there, the origin and insertion. And when we'll talk about this in a minute here, but when we flex our bicep, right, we're closing that joint at the elbow, and that moves our entire lower arm. All right, so with this, muscles work in pairs, and we think of it, we're going to stick with that biceps example, right? When I contract my biceps, well, that's great that my arm's up here now, but how do I get it back down? So we need a complementary muscle, or a muscle that works in a pair, to do this. So because muscle cells can only contract, they can't extend or they can't push, they have to work in pairs. So while one muscle contracts, the other muscle in pair returns that muscle to its original strength, to its original length, right? So our bicep gets really, really short here. Well, what's that muscle down here underneath that works opposite? The tricep, right? So when I contract my tricep, it now brings that bicep back to the original length. And we have kind of two types of these, or muscles, right? Or two names for when they work in pairs. We have flexors and extensors. So flexors, right, and you think about flexing, they bend parts of your body, and extensors straighten parts of your body. And obviously we like the bicep tricep because that's a really easy one. We have the same things in our wrist, right? We have flexors and we have extensors. All right. We have those all over our body. So when a muscle works in pairs, flexors and extensors, those are the two types or categories of pairs. So what is how do our muscles and bones actually work together to do work, right? To move stuff? Well, it has to do these things called levers, all right? And I'm sure that you learned back in middle school probably, or maybe freshman physics if you took that, about levers, right? It's a tool that helps us accomplish work, all right? It gives us a mechanical advantage. So bones and muscles make levers, and it's a type of machine, right, that makes it easier to lift and to move things. And I have this little picture here that really represents it. Again, really going back to middle school or maybe freshman physical science if you took that. We have this green thing represents a fulcrum, right, which is where the lever kind of rests on, okay, and it pivots at the fulcrum. And then we have the actual lever, right, which think about as like a straight piece of wood or a bar or something like that. So if you have a fulcrum in the middle here, I could push down on this lever to lift up a load. All right. Great example would be like if you're trying to pick up a heavy log, right? You can take another log, take a piece of wood, put it over it, and then push down and lift up that really heavy load. It really gives us an advantage for how much we can lift. And there's other types of levers, right? Your class 2, your class 3, where the fulcrum's over here. You could lift things up. You could put it over here, put things up. So I'm not going to get into that too much because that's so long ago, right? But just knowing that our muscles and bones work together to make levers or levers, right, to do work and to have a mechanical advantage where a smaller effort can move a heavier load. And that makes sense. And if you think about evolution, right, why would our body be built of all these different levers and fulcrums? Well, the strongest ancestors survive. So whoever could do the most work for the least amount of effort, it's going to be a real advantage to the body. You're going to have to use less energy. You'll be able to move faster, jump higher. Really cool stuff. And you can see the picture's a little small here, but you can actually calculate that mechanical advantage of your muscle contracting a joint, right? So you can calculate it from the length of the effort arm, so the muscle movement, divided by the length of the resistant arm or the joint movement. So there actually is a way to calculate the mechanical advantage you're creating in joints. All right. But the big thing here is that muscles and bones work by making levers and fulcrums to make our work easier. Okay. So that's kind of how muscles work, right? But now we're going to talk about how do we name these muscles? So do you know there's over 600 muscles in the human body? Really cool. And they each have their own name. And as we start to get more back into our cat dissections and looking at the muscular system, we're going to have to learn a lot of those names because we actually share a lot of the same muscles as cats do. And there's 7 criteria or categories that we use to name muscles, and you can see them below here. But we're going to go more in depth on each of these. So you don't have to write them down just yet. We'll get right through them. All right. So again, these are really important to know because as we do practical work and in-person work to learn and identify and memorize some of these muscles, it's going to make it that much easier if you understand what the name actually means. It'll be a lot easier to actually identify it. Okay, so the first one would be location, right? So where is that muscle located on the body? Is there some type of landmark nearby that we can name it after? And I'm just going to go through some of these examples here, right? So the frontalis, okay, is on the frontal bone. Lateralis is on the side. Here's a great one, and this is our example here. Tibialis anterior, all right? Remembering way back to our first chapter in anatomy, anterior means towards the front, right? And tibia is that your shin bone. So tibialis anterior, right? It's a muscle that runs down the front of our tibia, okay? Some other ones here, supra above, infra below, sub underneath, those prefixes that we know, right? Fibularis longus. We'll talk about longus here in a second, but near the fibula on the back. So our first scheme is by location. All right, our second naming scheme is shape. So our muscles can have all types of funky shapes too. Our deltoid, right, up on our shoulder, it's just cut off a little bit here. It's a muscle that shapes like a triangle. All right, latissimus means wide. Teres round. So our trapezius muscles, like if you ever work out your traps up here on your upper shoulder to your upper back, right? It's a trapezoid. And you can see that like trapezoidal shape here. I'm no geometry expert. Ask Mr. Liljegren on that one. But yeah, a trap, right? Your trapezius muscle is actually a trapezoid shape. Okay, a serratus muscle is sawtooth, like a serration. All right. So shape is another way we can name. Our third one is by size. All right. And a lot of times these names, the maximus, minimus, they'll be probably coupled with another name for either location or insertion or shape or something like that. So like you can see here, our pec muscles right up front on our chest when we're bench pressing, right? That's actually our pectoralis major, okay? And that major means large, right? Maximus, minimus. So another one, probably our favorite one we all know, gluteus maximus, right? That's our muscle that comes down on our butt, okay? Maximus means largest. It's the largest of our gluteus muscles. You can see these other descriptors here for size. So size is another way we name muscles. All right, now we have direction of the fibers. So which way the muscle actually runs. All right, when we think about running, like when we say how the fibers run, if you've ever like cut into a piece of steak or chicken, right, you see how it's got like a grain, we call it, if you're into butchering and meat, right? Always cut against the grain. Well, that grain is how the muscle fibers are actually running. So when we name some of these muscles for direction or orientation, we're talking about which way they run. So the transversus, right? It's transverse, or that transverse plane that goes across the body, all right, at right angles to the muscle's long axis. So this would be the long axis, so transverse, right? Rectus abdominis, all right? So rectus would be straight, so straight along the abdomen. Again, our obliques, okay, that come in on the sides. Oblique would be an angle. So direction or orientation. All right, another one here. So the number of origins, and we just talked about origins, right? Where a muscle actually attaches to the bones, and it needs to attach so that we can actually contract and move bones one way or another. So number of origins, right? Biceps brachii. So brachii location, biceps, two heads where it attaches. You can see here, right? It's got two attachments, all right? Our triceps, which is inferior to that, has three origin, like a tricycle, triceps brachii. Our quadriceps femoris, all right, quad, four origins. So if we were to look down at the muscle on our leg, our quads, right, we'd see it had four of these attachments, and then femoris, right, located near the femur. So number of origins is another big way that we name muscles. Okay, so origin, now we can call it for another naming scheme is where they originate or have insertion points. And this is a great, one of my favorite ones here, the sternocleidomastoid, right? So if we break that into three parts, the sternum, right, our center chest bone, you can see it attaches at the top of the sternum here. Cleido for clavicle, and this is your clavicle or your collarbone here. You can see it has some attachments there. And then your mastoid, right, which is up here on your temporal bone, okay, where our masseter, which is another muscle for our jaw, right, the one that runs this way that gives us our jaw power, where that attaches. So just a really cool muscle name, sternocleidomastoid. So if you ever like had a weird strain in your neck that kind of shoots down this way, you probably pulled that muscle, okay? And again, sternocleidomastoid, sternum, clavicle, mastoid. All right, really cool name for origin and insertion. All right, and then muscles named for action. So I kind of alluded to this before, but our flexor carpi radialis. Whew, okay, well, carpal, we'll learn about this when we do the skeleton, right, is our wrist bones. Flexor, we know means, right, flex, shorten like that. And radialis, our bone here. So flexor carpi radialis. The opposite muscle on that, on the backside, let's see, do you know what it is? Take a guess. If you said extensor carpi radialis, you would be correct. I feel like I was on Dora the Explorer or Blue's Clues there, waiting for the answer. All right. Abductor magnus, right, abducts the thighs, and we'll talk about what that word means in a second. Extensor digitorum, right, extends the fingers. Flexor digitorum, flexes the fingers. Levator, lifts a structure. So all these actions can be incorporated into muscle names too. And so that's I think we hit our 7 naming schemes, right, for muscles. And again, this is the last slide that we were on here. So flexor carpi radialis, just a great example for how we can incorporate some of these different naming schemes together to create names for muscles. And like I said at the beginning, if you really take your time to know the ways that we may name muscles, it'll be a lot easier to remember them, because you may have to think about, oh, when you're looking at a cat or a human, what's this muscle? Let's see. Well, it definitely flexes the wrist, which is the carpi, and I see it attaches to the radius. Oh, that's the flexor carpi radialis. And on this side, I see it extends the carpal bones, and it attaches to the extensor carpi radialis, right? So knowing those naming structures really, really helps for remembering muscles. And like I said, there's over 600. These are some of the big ones. We're going to look at these in humans. We're going to look at these in cats. So you're going to have to know these. All right, both an anterior and posterior view here. Okay, so just how do we use these muscles and bones that work together to create mechanical advantage through levers? All right, and we can name them. How do we do different types of motions? Right. So looking at some of these motions, and we talked about, right, flexion versus extension, right? So flexing, closing a joint, extension, straightening back out. We have rotation, right? I can rotate my neck with joints sometimes pivoting each other over that. I just put them together on the same line, abduction or adduction, all right? So adduction is coming to the body, and you can see if you had your arms out and you bring them down, think about that you're adding, right? You see that ADD. You're adding to your body. So you're bringing your arms to your side. All right. Sadie wants to demonstrate muscles here. You're not a dissection cat. All right. So abduction is when you bring something away from your body. Think about like, I'm being abducted, right? The movie Taken. I'm being abducted. I'm being taken away. So you see the arms coming up here away from the body. And then circumduction, right? That's for really a freely movable joint like our shoulder, right? Where we could do like these big circles would be circumduction. So those are some of our movements. All right. So, hey, that was a quick one, but I think we got through quite a bit there and really important stuff. So make sure you go back, you get everything that you may have missed, and just be prepared for that in class and for looking at it when we look at cats. So, hey, stay tuned. We'll see you on the next one.